This video is about sinusoidal modeling. That's where you model a situation using sine or cosine. This is AP Precalculus topic 3.7. If you appreciate this content, please give it a like. Number 1. The graph of the sinusoidal function h is shown in the figure above. The function h can be written as h of theta is equal to a times the sine of b theta plus d. Find the values of the constants a, b, and d. Notice that the c is missing. The c would normally be right in here, and the fact that it is missing means that c is equal to 0. That means there is no phase shift. The lack of a phase shift means that one period of the function starts right here at 0, like this. Notice that this period is an upside down sine function, so the a value will be a negative number. The a value corresponds to the amplitude, which is the distance between the midline and the maximum value. In this case, the amplitude is 3, therefore the a value will be negative 3. Now it's time to find the b value, but to find the b value, we start with the period. Since this period begins at 0 and ends at pi, the period is simply pi. We have memorized that the b value is always given by 2 pi divided by the period. So 2 pi divided by pi. The pi's cancel each other out, leaving b equals 2, which goes right here. That just leaves the d value, which corresponds to the midline. Since the midline is at y equals 1, the d value is positive 1. You can record your final answer like this, or leave it like this. Number 2, let's start by drawing the midline. Halfway between the highs and lows, the midline is right here at negative 1. We notice that once again, there is no c value, or you can say that c is equal to 0. That means there is no phase shift, which means that one period of f will begin right here at 0, right here. This is a right side up cosine function, so the a value will be positive. Specifically, the a value will equal the amplitude, which is 4. For the b value, we start by identifying the period. Since this period begins at 0 and ends at 4 pi, the period is 4 pi. The b value is always given by 2 pi divided by the period. So in this case, that's 2 pi divided by 4 pi. The pi's cancel out, and we are left with 2 over 4, which reduces to 1/2. So b is 1/2. The d value corresponds to the midline. Since the midline is at y equals negative 1, the d value is negative 1. You can record your final answer like this, or leave it like this. Number 3. The figure shows the graph of a trigonometric function h. Which of the following could be an expression for h of x? Compared to the parent function, function a is an upside down sine function because of the negative a value. So, starting at the phase shift, one period will look like this. The c value is 0, so there is no phase shift. So one period is going to begin right at 0. However, when we trace out this first period, it is a right side up sine function, not the upside down sine function we were looking for. Therefore, option A cannot be the answer. Function b is a right side up sine function because of the positive a value. So one period starting at the phase shift will look like this. The c value is negative pi, so the phase shift is the opposite of that, which is positive pi. So one period of function b will start right here at positive pi. If I trace out one period starting at the phase shift, it looks like this. This is an upside down sine function, not the right side up sine function we were looking for. So option B is not the answer. Function C is an upside down cosine function because of the negative a value. Therefore, starting at the phase shift, one period of function C will look like this. Since the C value is negative 3 pi over 2, the phase shift is positive 3 pi over 2. So one period of function C will start here. If I trace out one period of h starting at positive 3 pi over 2, it looks like this. This is the upside down cosine function we were looking for. So the answer is going to be C. But let's follow through and see why D does not work. Function D is a right side up cosine function with a positive a value. So one period starting at the phase shift is going to look like this. Since the C value is positive pi over 2, the phase shift is negative pi over 2. So one period will start right here. If we trace out one period starting at negative pi over 2, it's going to look like this, which is an upside down cosine function, not the right side up cosine function we were looking for. So that's why option D is not the answer. Number 4, the figure shows the graph of a trigonometric function g. Which of the following could be an expression for g of x? The positive a value tells us that function a is a right side up cosine function like this. So starting at the phase shift, one period of function a should look like this. Since the c value is 0, there is no phase shift. So one period will begin right at 0. If we trace out one period starting at 0, it looks like this, which is an upside down cosine function, not the right side up cosine function we were looking for. So function a cannot be the answer. The positive a value tells us that function b is another right side up cosine function. So starting at the phase shift, one period of function b should look just like this. Since the c value is negative pi over 4, the phase shift is positive pi over 4. So one period will begin at positive pi over 4. If we trace out one period starting at pi over 4, it looks like this. However, this is a right side up sine function curve, not a cosine curve. So B cannot be the answer. The negative a value tells us that function C is an upside down cosine function. So one period starting at the phase shift will look like this. Since the C value is negative pi over 2, the phase shift is positive pi over 2. If we trace out one period of function g starting at pi over 2, it looks like this. But this is a right side up cosine function, not the upside down cosine function we were looking for. So option C cannot be the answer. By the process of elimination, we know that option D must be the answer, but let's follow through and see why. The negative a value tells us that function D is an upside down cosine function. So one period of function D starting at the phase shift should look like this. Since the c value is negative pi, the phase shift is positive pi. If we trace out one period of g starting at pi, it looks like this. This is the upside down cosine function we were looking for, confirming that the answer is D. Number 5. The graph of h and its dashed midline for 2 full cycles is shown. 5 points, F, G, J, K, and P, are labeled on the graph. No scale is indicated and no axes are presented. The coordinates for the 5 points F, G, J, K, and P are as given here. The function h can be written in the form h of t is equal to a times the cosine of b times t plus c plus d. Find the values of constants a, b, c, and d. One period of the parent function y equals cosine t looks like this. So let's pick one period of h that looks like the parent function. If we pick a period that looks like the parent function, the a value will equal the amplitude, the distance between the midline and the highest value. 64 minus 50 is 14, so the a value is 14. Now it's time to find the b value, but first we're going to need the period. The period will be the horizontal distance from peak to peak. From an input value of 4 to an input value of 16 is a difference of 12. So the period is 12. 16 minus 4. We know that the b value will always be 2 pi divided by the period. So in this case, 2 pi divided by 12. This reduces to pi over 6. So that's the b value. The c value will be the opposite of the phase shift, and the phase shift is the first input value of the period. So in this case, the phase shift is 4, so the c value will be negative 4. That just leaves the d value, which corresponds to the midline. Looking at the output values of the points that are on the midline, we can see that the midline is y equals 50. So the d value will be positive 50. You can either record your answer like this or leave your answer like this. Number 6 is the same type of problem with new input-output pairs, and this time h of t is a sine function. We have memorized that the parent function y equals sine t looks like this. So let's pick a period of h that looks like the parent function. If we pick a period that looks like the parent function, the a value will simply equal the amplitude, the distance between the midline and the maximum value. The distance between negative 6 and negative 2 is 4. So the a value is 4. In order to find the b value, we first need the period. But from peak to peak, the first input value is at 0, and the next peak is at 4 pi. That means that the period is 4 pi. The b value is given by 2 pi divided by the period. So in this case, that's 2 pi divided by 4 pi. The pi's cancel out, leaving 2 over 4, which reduces to 1/2. So the b value is 1/2. The c value is the opposite of the phase shift, and the phase shift is the first input value. So we need to figure out what the first input value is. Let's look at how the input values are changing from point to point. It goes from 0 to pi to 2 pi to 3 pi to 4 pi. So going to the right, it is increasing by pi each time. That means as we move to the left, it is decreasing by pi. So the next input value to the left will be negative pi. And might as well throw in the output value. Looking at the other 2 points that are on the midline, we see that the output value is negative 6. So this point is negative pi, comma, negative 6. So this first input value is the phase shift. The c value will always be the opposite of the phase shift. So the c value is positive pi. That just leaves the d value, which corresponds to the midline. Looking at the output values of the points on the midline is y equals negative 6. Therefore, d is also negative 6. You can either record your answer like this or leave your answer like this. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.